Antarctica's hidden underwater canyons hold some of the ocean's most breathtaking yet mysterious landscapes, and scientists are only beginning to uncover their secrets. These submarine canyons, especially those surrounding remote polar regions like Antarctica, remain largely unexplored and poorly understood on a global scale. But here's where it gets controversial. Recent research reveals these undersea valleys may play far more critical roles in oceanic processes and climate dynamics than anyone previously suspected. A groundbreaking study published in the journal Marine Geology has unveiled the most comprehensive mapping of Antarctic submarine canyons to date, cataloging an astonishing 332 canyon systems, with some plunging deeper than 4,000 meters. This represents a five-fold increase over earlier surveys and marks a significant leap forward in polar marine geology. The research was spearheaded by David Amblas of the University of Barcelona's Faculty of Earth Sciences and Ricardo Arrocio from University College Cork's Marine Geosciences Group. Their findings underscore the potentially pivotal influence these submarine canyons exert not only on ocean currents, but also on ice shelf stability and ultimately on global climate change, particularly in sensitive zones like the Amundsen Sea and areas of East Antarctica. But this is the part most people miss. The complex interplay between these canyons and climate processes is still woefully underappreciated in current models. Submarine canyons are essentially underwater valleys carved into the seafloor. They're incredibly important because they act as conduits, transporting sediments and essential nutrients from coastal zones out to the deeper ocean. This sediment transport supports diverse marine ecosystems and connects shallow waters with the deep sea, thus fostering biodiversity hotspots. Globally, scientists have identified about 10,000 of these canyons, but since only roughly 27% of the seafloor has been mapped in high resolution, the true number is likely much greater. What makes Antarctic canyons particularly unique is their size and formation process. Amblas explains these features tend to be larger and deeper than many found elsewhere due to the persistent action of polar ice and glaciers pushing vast amounts of sediment onto the continental shelf over millennia. In Antarctica, powerful turbidity currents, fast-moving flows of sediment-loaded water, carve and shape these canyons as they rush down steep undersea slopes. The abundant glacial sediments in the region amplify these erosive forces, resulting in massive canyon structures. The recent study leveraged version 2 of the International Bathymetric Chart of the Southern Ocean, IBCSO V2, which provides an unprecedentedly detailed map of Antarctica's seafloor. The researchers combined this rich data with a semi-automated analysis approach they developed themselves, allowing for more objective, large-scale identification and detailed investigation of canyon networks. In total, they evaluated 15 different physical characteristics of these canyons, revealing stark contrasts between those in East and West Antarctica. Here's what's fascinating and potentially controversial. East Antarctic canyons tend to be more intricate and branched, forming extensive systems with characteristic U-shaped cross-sections. This indicates long-term sculpting under steady glacial forces, influenced by both erosion and sediment deposition. On the other hand, West Antarctic canyons are generally shorter and steeper, with V-shaped cross-sections, suggesting a different geological history and glacial dynamics. Arrocio notes that this newfound morphological contrast supports the theory that the East Antarctic ice sheet is older and has been uninterruptedly active for a longer time than previously understood, a conclusion previously suggested by studies of sedimentary records, but now confirmed through seafloor shape analysis. The improved resolution of IBCSO V2, offering data at 500 meters per pixel compared to the previous 1 to 2 kilometer resolution, enabled the researchers to apply sophisticated, semi-automated GIS tools with greater confidence. This technological advancement allowed them to comprehensively profile each canyon and their drainage networks, making the analysis faster and more precise than earlier manual techniques. Beyond their geological fascination, Antarctic submarine canyons are vital players in global climate regulation. They serve as channels that facilitate the exchange of waters between the deep ocean and continental shelf. Cold, dense water formed near ice shelves flows through these canyons into the ocean depths, contributing to the formation of Antarctic bottom water, a key driver of global ocean circulation that influences climate worldwide. Conversely, the canyons also guide relatively warmer waters, like circumpolar deep water, closer to the Antarctic coastline. This process accelerates the melting and thinning of floating ice shelves, which act as gatekeepers maintaining the stability of inland glaciers. When these shelves weaken or collapse, the glaciers behind them accelerate their flow into the ocean, raising global sea levels. And here's where debate heats up. Current global ocean circulation and climate models, notably those adopted by the Intergovernmental Panel on Climate Change, IPCC, fall short in accurately simulating these localized interactions between water masses and complex submarine topography like canyons. Important mechanisms such as current channeling, vertical mixing, and deep water renewal in these intricate environments remain underrepresented in models, limiting their capacity to predict future ocean and climate behavior reliably. Both Amblas and Orosio emphasize that the path forward must involve continued collection of high-resolution seafloor data from uncharted areas, along with enhanced observational studies using both in-situ instruments and remote sensing. Moreover, refining climate and ocean models to incorporate these fine-scale processes will be crucial to produce more trustworthy forecasts of climate change impacts. So, what do you think? Are we underestimating the true influence of these hidden underwater valleys on our planet's climate balance? Could improving our knowledge of submarine canyons unlock new insights into combating climate change? Or is this just another niche area with limited global repercussions? Feel free to share your thoughts because bold questions like these make science progress. Reference: Orosio, Ricardo, and David Amblas. The Geomorphometry of Antarctic Submarine Canyons. Marine Geology, June 2025. DOI 10.1016/J.Maggio.2750 10768. Open access.